Bismillahirrahmanirrahim. Welcome to all of you over my YouTube channel, Explore Mechanical Engineering with Saqib Nasir. I welcome to all of you over this channel. Today I am going to explain a very basic concept in fact in all engineering and science field, that is concept of continuum mechanics. So before giving an introduction of continuum mechanics, I will explain to all of you the theory behind continuum mechanics. So let's start. For example, I have this piece of matter. Why I am calling it as matter? Because matter can be solid or fluids. So before starting our discussion, I would say at this stage there is no difference between solids and fluid. I will collectively call it as a matter. And instead of matter, I will call it as a material. Okay, and you all know material can be solids and fluids. What if I will apply a loading over it? I will apply a loading. So when I would say a loading in engineering or science term, so the first thing that come into mind is the mechanical loading, like you're pressing something. But in engineering or in science field, loading can be thermal or mechanical. Okay, so in thermal loading means you are providing heat or removing heat. Mechanical means you are applying force or doing work. And we all know force can be body or surface. Okay, body force, the force which is acting over the volume of a whole body, and surface means the force which is applying over the area. Like when I would say, when I apply compressive force over a material, it is called a surface force. So let's say I am applying a loading. So in order to comment more generically, I will use the generic term loading, and I have explained you the true meaning of loading. Loading can be thermal or mechanical. I have this material, and material can be solid or fluid. This is a generic introduction of continuum mechanics. When I will apply this loading over this material, so what you guys think, what will happen within this material? There could be two possibilities. The first one is it will deform. Second one is it will not deform. So the material which do not change its shape under the application of loading is called rigid structure, rigid material. And the material which deform under the application of load is called deformable bodies. So what you guys think, the deformable bodies, when I will talk about deformable bodies, which first thing come into your mind, that whether it can be a fluids or it can be a solid. Obviously, all fluids are deformable bodies. So how fluid can deform, I will explain maybe in later videos, but you can imagine easily in terms of solids. So when you apply a compressive force over a solid material, whether it can sustain or it can deform. So if a material deform under the loading, if a material is deformed under the loading, then with this deformation, a material, as a result of this deformation, or rather I would say, as a result of this applying loading, material will generate internal stresses, and stresses can be mechanical stress or thermal stresses. Got my point? Material can be thermal or mechanical stresses. So if I would make a generic comment over all this discussion, I have a scenario when I have a material and I am applying a loading over this material, and how material will behave under this application of loading. How material will behave under the application of this loading is how material will behave under the application of loading is addressed in continuum mechanics. Alright, so continuum mechanics basically does not deal with this rigid body material. Continuum mechanics will not deal with the rigid body mechanics. Continuum mechanics deal with the deformable bodies. We deal only with the deformable bodies. So I have a scenario, I have a problem in which I am applying loading over this deformable body, and my claim is that how this material will behave under this application of loading. So if I would like to analyze this structure, this problem, analyze this problem theoretically. Theoretically mean mathematically. If I would like to analyze this problem analytically, theoretically, then I would say I will apply all theories of mechanics over continuum body, over this continuum body. Strange, this is a difficult concept, so let's try to comprehend this concept. So what are the laws of mechanics? I have the scenario that I am applying load over a deformable body. Now I want to conduct a theoretical analysis. So before conducting theoretical analysis mean to make a mathematical model. Alright, so how to make a mathematical model. Mathematical model mean to predict the behavior of a material. So to make a mathematical model or to conduct analytical analysis or theoretical analysis of that material which undergoes deformation by the application of loading will be addressed under continuum mechanics. How we can address? We will apply all concepts of mechanics over continuum body. This is called continuum mechanics. So it is a bit simple. So laws of mechanics applies over continuum body. All right, continuum body. So laws of mechanics, we have basic conservation laws. Basics. Can you recall the laws of mechanics? The first one is basic conservation laws. Like conservation of mass, conservation of momentum, linear or angular momentum, all right, and the second one is laws of thermodynamics. These are the basic fundamental laws governed by mechanics of bodies. So the next step is we have these fundamental laws and we will apply these fundamental laws over continuum body. So now we will clear a concept of continuum. What is continuum? So I will again start from this problem. When I would say how the material will behave under this loading, you have two options. In order to analyze this problem, you have two options. The first one is that you start analyzing every particle of this body. How many particles? If I would ask how many particles a 1 gram of copper has, you would say one Avogadro number, like 6 into 10 raised to 23 particles in 1 mole of a gas or in 1 gram of a solid material. You have to analyze such quantity of particle in 1 gram of copper, for example, and what about one particle, one atom? You have to analyze one nucleus with so many number of electrons. So in order to make it more complicated, I would say not only the study of electrons and protons, not only the study of nucleus and motion of or dynamics of electrons, you have to incorporate time also. So how can you analyze the material? Well, with this application of loading, when especially when you start analyzing a material over a discrete points, how can you analyze when you have to deal with such a huge amount of particle, also incorporating the dynamics of charges within a single atoms and also incorporate the dynamics with respect to time? It would be such a complicated thing. By the way, this analysis, particular analysis, is called quantum mechanics. What it is called? Quantum mechanics. Now I am sure that You will get my point. So the continuum mechanics, when you will listen the word continuum mechanics, the first thing that come into your mind is the quantum mechanics. So quantum mechanics is the study of discrete particles present within the bodies, but it make a problem much more complicated, because in a real situation we don't need, in many of cases we don't need to study every particle of a material. For example, you have a watch in your hand. So in watch, in which thing you are most interested? You are most interested with the motion of the needles, only needles. You are not concerned about what the internal machinery, how the internal machinery is working. You are not interested. You are only interested in the motion of the needles of a clock. So similarly, likewise, in many problems you are not interested to analyze a material on a particular base. So you change your approach to analyze the material. Like, instead of analyzing over every particle, you consider a material macroscopically. For example, what is the meaning of macroscopically? Macroscopically means to view or to divide the material as small as which can be analyzed. Alright, so we divide a material. For example, I have this copper string. I will divide it into two parts, then 4, then 8, then 8. How much the small size I have to divide it, until I have this small chunk. I have this small chunk of this copper wire, and now I will apply the laws of this is my continuum body. So continuum body, I have divided macroscopically. Continuum body, the basic assumption of continuum body, it is a continuous media. So I know, with the power of continuum mechanics, I become independent of the particular nature of the material. I am considering it a infinitesimally small particles, and considering it as a continuous media and calling it as a continuum body. So let's start. So at the start, when I started this problem, how this material will behave under the application of the loading, the question is now a little bit clear, that a material, if the material will deform, then if the material will deform under the application of the loading, I can apply the concept of continuum mechanics instead of analyzing it by using quantum mechanics. So for continuum mechanics, I will take a chunk. I will suppose a body infinitesimally small, which over which I can easily apply the laws of mechanics, over which I can easily apply the laws of mechanics and laws of mechanics. So laws of mechanics, and we will develop a mathematical theory, a mathematical theory. So continuum mechanics provide a foundational theories over a deformable bodies and will help to make a mathematical models of balance laws. So by using the concept of continuum means you are considering a continuous media and you are applying a concept of mechanics over this continuous media. This continuous media can be fluid or can be a solid, but which material? That is deformed under the application of loading. So you have to make the mathematical theories, the differential equations of balance laws, law of conservation of mass, law of conservation of momentum, first law, second law. So you have to make a conservation mathematical theories or differential equation including balance laws. So three equations of balance laws: conservation of mass. One is conservation of mass and second is conservation of heat. So you have conservation of heat is a two equation. I would explain it on a later basis. Two equation of conservation of heat, one equation of conservation of mass. So three equations of conservation of momentum. So you have total three. So you have four equations and one inequality. Okay, you have four equations and one inequality. So how to solve the differential equations, like conservation of momentum, conservation of mass. In my later videos I will explain the exact mathematical expression of these of the material, but up till now I did not define my material. I did not say. I am talking about generically. I am not specific with the fluids or solids. I am not specific. I am saying I am making a mathematical theory, a mathematical foundational theories of a body which undergoes deformation by the application of loading. Okay, so once I will make a mathematical theory by applying mechanics laws over a continuum bodies, so I would end up with the four equations and one inequality. So in order to solve this problem, in order to solve this problem, I have to differentiate my material. So the relations which correspond to the material under the application of the load is called constitutive relation. Constitutive relations. I know my video is getting longer, so I am trying to summarize my discussion. So constitutive relation is basically differentiate a material. No, at this stage when I will formulate my constitutive relation, then I will say my material is copper, my material is fluid, my material is viscoelastic, whatever. So for formulating the constitutive relations, I would say I would specify the particular type of material, and no, I will analyze this loading and I will formulate my constitutive relations. Let's say, for example, let's say in these four equations and one inequality, I have 7 unknown. I will explain later on. So in order to close this system, I have 4 equations and 7 unknown. So I have to make 3 constitutive relations in order to close this system. So in order to close this system, we have to make 3 constitutive relations. So I would say my system is closed. Now I can get its analytical solution. But we cannot make a constitutive relation in every situation. We cannot make. So what we can do? We can do its analysis by numerically, like we do in FEM. I will explain this concept also later on. Okay, got my point? So summarize, I will summarize my discussion. First one is loading, applying over deformable bodies, assumption is continuum, mean continuous media, continuum, laws of mechanics. When you will apply laws of mechanics over this continuum body, you will end up a system of equations which defines the behavior of system of equation. Up till now, when you have 4 equations, 3 equations of conservation of momentum, 1 equation for conservation of mass, 2 equation of conservation of heat. Up till now, we did not classify the material. So the stage where we define our material is the constitutive relation in order to close our system. So when we formulate the constitutive relation, there are different rules which we obey in the formulation of constitutive relations. So I will describe these relations in my later videos. So constitutive relations, once we formulate our constitutive relation, we can get analytical solution, but we are in some situation where we are not able to define a constitutive relation, we move toward the numerical solution by using FEM. So numerically we have different approaches like finite difference method, finite element method, finite volume method. So I will explain all these methods later on. So I hope you got my point. In this video series, I will explain the true concepts of quantum mechanics. So I hope those students who are pursuing their master or who have ambitions to get admission into PhD, this video series will be beneficial to all of those candidates. So I hope you guys have enjoyed my video. If you feel that my language is not clear or my level of explaining these concepts are a little bit complicated, so you can make a comment over this video. I will try to make next video more elaborately and more expressive and easy way. Thank you very much. Take care. Bye bye.